All right, this section 10.3 hypothesis test for the population mean. So we did the population proportion, and then we did the population mean, and then we're going to do 10.4 population standard deviation for testing for hypothesis. So to test the hypothesis regarding the population mean, assuming that the population standard deviation is unknown this time, so you will use the t distributions rather than the z distribution, where we replace the sigma with the s. So when we have a population proportions, we love to use a z distribution, and then for the population mean, we want to use a t distribution, and then when we have a population standard deviation, we are using the chi-square distribution. So we are using kind of different distribution, okay? So follow the student t distribution with an n-1 degree of freedom. So property, this is the review for property. So property of the t distribution, number one, t distribution is different from the different degree of the freedom. Number two, distribution is center at 0 and symmetric about 0. And then 3, the area under the curve is 1 because of symmetry. The area under the curve to the right of the 0 equal to the area under the curve to the left of the 0 equals half. As t increases without bounds and the graph approaches the but never equal to 0, and the area in the tail of the distribution is a little greater than the area in the tail of the standard normal distribution because using s as an estimate of the sigma introduces more variability to the t statistic. And then number 6, as the sample size n increases and the density curve of the t gets closer to standard normal density curve. So this results to occur because as the sample size increases, the values of s get closer to the value of the sigma by the law of the larger number. All right, next page. The testing the hypothesis regarding a population mean. To test the hypothesis regarding the population mean, we use the following step to provide that. So that 3 steps must be satisfied. So first one is sample is obtained using a simple random sampling. The sample has no outlier, and the population from which the sample drawn is normally distributed, and the sample size larger, which is n must be greater or equal to 30. And the sample value are independent of each other. So step 1, we're gonna have 3 ways of the hypothesis test. So two-tail, left tail, right tail. And then the two-tail means we're using the sigma this time. We're using the mu this time, which is a mean. So the null hypothesis are all the same as always equal to. And the alternative means not equal to, less than for left tail, and greater than for the right tail. So you'll see which hypothesis test you have to use from the problem. In step 2, we have to find the level of the significant alpha. Okay, and then that actually we can avoid the type 1 error, which follows the student t distribution is t equal to n-1, and then degree of the freedom. And then this is actually the test statistic we're going to actually use in here in the step 3. So classical approach. Use the table 7 to determine the critical value. So you'll see the t distribution, which is we did in class. So two tails has the critical region as both sides, right? So the statistic test statistic falls in the critical region, we need to reject the null hypothesis. The left tail we have it on here, and then for the right, this is a right tail, so I don't know why I'm missing it. And the right tail is going to be on the right here. So on the critical values, compare the critical value, we have to put we compare these values together here. And then for the left tail, we compare these numbers to these numbers, okay? And then if that's satisfied, we reject the null hypothesis. And then p-value approach, which is we are using the test statistic and then using the alpha. So student t distribution with an n-1 degree of freedom. And then using the table 7 to check with the value. So p-value, this is the formula for p-value. P-value that and p-value that, okay? On the left and the right, and then on the left tail and the right tail. And then also you can use a technology to figure out the p-value too. And the important thing is step 4. Now you compare the p-value to the alpha. So if that is satisfied, we reject the null hypothesis, and then we say the conclusion. But the procedure is robust, which means that the minor departure from the normality will not adversely affect the results of the test. However, for the small sample, for the data have outlier, procedure should not be used. Okay. All right. Let's go to the next page. All right. So example 1. So I'm using the three example here. All right. So let's go for the first example. So we test the hypothesis about the population mean has a large sample. So assume that the testing metabolic rate, RMR, of the healthy males in complete silence is 5,710 kJ per day. Researchers measured the RMR of 45 healthy males who were listening to classical music and found their mean RMR to be 5,708.07 with a standard deviation of 992.05. And then at the alpha equal to 0.05 level of the significance is evidence to conclude that the mean RMR of male listening to classical music different than the 5,710 kJ per day. So let's do the step 1. So in step 1, we have to set up the null hypothesis, which is we have a mean, which is a 5,710. We are using those numbers, okay? And then 45 later as an and then this is actually the number that we had it in as a standard deviation for the sample. And then we need to compare, and then vice versa. And then mu is, this is actually say that it's different. So which means I'm using the not equal to 5,710. And then step 2, we need to find the level of significance, which is alpha, which is a 0.05 level. And then step 3, now we have to find the test statistic, okay? So in order to find the test statistic, we have to find the x bar, which is 5,708.07, and also the standard deviation, which is 992.05. So test statistic, which is t sub 0, and then formula is x bar minus mu over s over square root of n. Plug it in. X bar is 5,708.07. Subtract 5,710 over 992.05 divided by square root of 45. There's a 45 male, right? It becomes negative 0.013. So this is what we need to keep it for later. And then we can split as a classical approach. And then we can have a p-value approach. So in step 4, in the classical approach, we know that this is a two-tail because it's not equal to. And then the critical value at the alpha 0.05 level of the significance and minus 1 equal to 45 minus 144 degree of the freedom. So what we need is we have to find it negative t sub alpha over 2, which is negative t alpha is 0.05, become negative t 0.025. And then if you use a t table, which is the degree of freedom, which becomes 45 minus 1, which is a 44. So use the degree of freedom, and then use the 0.025, and then you earn the negative 2.021. But you might have a positive, but you need to put the negative of those, okay? And then also positive p so alpha over 2. This becomes 2.021. So in order to use that, if you put the curve, right, because the two tails always about negative t alpha over 2, and other side is a t alpha over 2, and then, so we got the number for that, right, of the each, this number and then this number, right, and then now we have to see that the where is the t sub 0 goes. So in order to find the t sub 0, this is a negative 2.021. This is a positive 2.021. So t sub 0 must be here, which is a negative 0.013, which means the test statistic does not fall into the critical region. So in the step 5, okay, we just say we fail to reject the null hypothesis. All right, that's the classical approach, okay? And then also the p-value approach, which is, I think this is more easier. Okay, so p-value approach is just a step 4. Of course, it's a two-tail. So you need to just do the one way, one of the way, right? You don't have to do the both ways, but I try to show you both ways. So we need to find the p-value here. So p-value is the area under the t distribution with the n-1, which is a 44 degree of freedom. So in here is a p-value is the formula we have from the previous page. Say p of t must be less than t sub alpha over 2 negative, right? So negative negative t is less than t sub 0, right? Okay, let me take a look. So in the t sub, yeah, absolute value of the t sub 0. All right, so this is negative 0.013 plus p of t is greater than 0.013. So it's going to be same as 2 of p of t is greater than 0.013, which means it's about 0.5. So in here, p-value, which becomes has to be less than alpha to reject the null hypothesis, but the p-value is 0.5, but the alpha was 0.05, which is 0.05 is not less than the 0.05, so we fail to reject the null hypothesis. So step 6 overall. So you can get the steps overall. And then you can just say there is insufficient evidence at alpha equal to 0.05. The level of significance to conclude the mean RMR of males listening to calm classical music differ from 5,710 kJ per day, which means I think it still stays the same. So we can say this different right now, okay? All right, let's do the next problem. In the next problem, we are using the small sample. Okay, so according to the United States, the mint, the quarters weigh 5.67 gram. A researcher is interested in determining whether the state quarter has a weight that is different from 5.67 gram. He randomly selects 18 state quarter, weight them, and obtain the following data. So those are the data we have. At the alpha equal to 0.05 level of the significance, is there evidence to conclude that the state quarter has a weight different from the 5.67 gram? So yeah, so we are using those, okay? So step 1, H sub 0, which is a null hypothesis, mu is going to be 5.67 versus, and alternative hypothesis mu is different, so not equal to 5.67. So when you said that, it's right here. And then step 2. And then we need to find the level of the significance, which is the 0.05, okay? That's what we need. Step 3. Now we have to find the test statistic, which is t sub 0, which is x bar minus mu of s over square root of n. So we just need to find it, okay? So, but is that given? Not really. But we have an x bar, but standard deviation, we have to find this. So I should use the formula that I gave you, okay? Or calculator, that's fine. So x bar is going to be 5.67 minus mu is now the... No, hold a second. I'm confusing myself. Okay, so you can find the x bar that add them up, right? Adding this all data and then divide by 18, right? So you get the 5.7022, and then mu is 5.67 divided by s. Also, you can find it as 0.0497 over square root of 18. Use a calculator, okay? And 2.75. So I need you to keep that in. It's important. So now we can do as a classical approach, which is now step 4. So this is two-tailed. And then the critical value at the alpha equal to 0.05 level of the significance with the n minus 1, which is 18 minus 1 is a 17 degree of freedom. The degree of freedom is 18 minus 1, which is 17. So since it's a two-tail, we have to find the t negative t alpha over 2. Is a negative t 0.025, but it's a degree of freedom, so I'm getting a negative 2.11. With the t alpha over 2, I'm getting a 2.11. Which means if I use a curve, and then the one side is negative 2.11, other side is a 2.11, and then this area becomes a critical region. So I want you to put that in, the 2.75, which is greater than 2.11, right? So this is t sub 0, which is, it falls in here, which is 2.75. So since the the test statistic falls in the critical region, now we have to do reject the null hypothesis. And then for the p-value, it will be the same. So it's a two-tail. So this is step 5. Sorry. Step 4. So it's a two-tail. But we need to find the p-value, which is going to be the p of t is, you're going to say, you have to say the t was, okay, so wait a second, let me see. I can find it here. Yeah, as a p value, so t is, sorry, yeah, that's what I thought. So t is greater than the value of t sub 0, right? Which is the same as p of t is less than negative t sub 0, which is 2.75, and plus t is greater than 2.75. So same as 2 times of p of greater than 2.75, and then use the degree of freedom as a 17 with the close. So when you look it up and the closest possible, and then it will becomes this number that you can find it in is actually the 2 of p greater than 2.17 will be, and between will be not the 2.75. What am I looking at? So 2.75 will be between the 0.01 and 0.02. Okay, so now step 5, we have to compare p-value, and then should be less than alpha, but we already alpha is 0.05, right? But p-value is going to be between 0.01 and 0.02. So any number between the 0.01, 0.02 is less than 0.05. So work, right? So that's why we reject the null hypothesis. So step 6, we can just state that, okay, and there is sufficient evidence to conclude that the mean weight is different from the mean weight is different from 5.67 now. Okay, all right. Okay, that's for the small samples. All right, what if we have the question that when is a larger sample size using hypothesis test, and the results could be the statistically significant even though the difference between the sample statistic and mean states in the null hypothesis may be no practical significance. So practical significance is referred to the idea that while small differences between the statistic and the parameter and the state in the null hypothesis are statistically significant, the difference may not be large enough to cause the concern or be the considered important. Okay, so let's get to another one here. So example 3 shows in 2003, average age of the mother at the time of her first childbirth was 25.2 age. To determine if the average age has been increased, a random sample of the 1,200 mothers is found to have a sample mean of age of the 25.5 with a standard deviation of 4.8. Determine whether the mean age has increases using a significant level of the alpha equal to 0.05. So step 1, h of 0 is going to be the h of 0 is mu is going to be say 25.2, right? But now they said from the sample it has been getting older, right? So mu is now greater than 25.2 because it becomes 25.5. And then step 2, we are looking for the level of the significant alpha, which is 0.05. And then step 3, we have a test statistic to find, which is t sub 0, which is x bar minus mu over s over square root of n. So x bar is going to be the 25.5 minus 25.2 over s is actually the 4.8 is a given, and then square root of 1,200 the woman, which equal to 2.17. Okay, so we need to keep that. And then for this time, I think I want to use the p-value. Okay, so step 4, and then so this is the right tail, and then the critical value alpha equal to 0.05, and then the going to be 1,200 minus 1, which is 1199. So and then the is must be p is t is greater than t sub 0, which is p is t is greater than 2.17. So if you use 1199 with the 2.17, and then you need to find the p-value, which is p is the t greater 2.17 is in between the 0.01 and 0.02. So step 5, now we compare to the p-value to the alpha. So p-value, you can see the starting from 0.1 and p-value is 0.02, alpha is 0.05. Yeah, it works, isn't it? So which means we reject the null hypothesis, which means now the age of the first childbirth moms is getting older, right? So step 6. Sorry, this must be step 5. So step 6, we can say there is sufficient evidence that the mean age of a mother at the time of her first childbirth is greater. But even though it's kind of greater, but it's not that significant because only the age was the difference between the 25.2 and 25.5. So still 25 years old, right? So this is really the practical significance in the age of the difference. Okay, all right. And then, so what's important thing is large sample sizes. A large sample size can lead to the statistically significant measures, while the difference between the statistic and parameter is not enough to be considered practical significant. All right, that's for the 10.3. Thank you for listening.